So good morning. So in continuation to the previous video, so we will solve some examples. So let us assume that we have circuit something like this. So this is 12 volts and this is 16 ohm and the source. So this is 120 at an angle 0 degrees. So this is voltage across resistor and this voltage across inductor, and this one is the source voltage and this is source current.
So is it continuation of yesterday or so you're going to repeat it again?
No, I'm not repeat. So this is the continuation of yesterday's.
Yes. Okay.
Okay. Right. So now the question is, so find out the power or so find out the average power delivered by the source. Find out the average power delivered by the source. And also calculate the value of VR and VL. So calculate I, VR, VL and the power.
Sir, for all we have to do average, sir.
Yes.
Only for average power only, sir, we have to calculate average.
Yeah, power. Yeah. We'll discuss more on what is average power, reactive power, and other terms in later classes. Right. So now, how to calculate current I? How to calculate current I?
V by 12 plus V by 16.
Voltage divided by impedance, so that is V by Z. So that will gives you the current, right? So what is Z here?
12 plus 16,
J, 12 plus J16, right? So this is in polar form. So we need to convert. This is also in polar form. So what is its equivalent polar form?
20
square.
20.
20 at an angle tan inverse
20
4 by 3.
What is that angle?
53.
15 by 12.
53
4 by 3.
4 by 3.
53 degrees.
1 degree.
53 degree.
53.1 degree, right? So here this is Z. So V value is 120 at an angle 0. So this is divided by 20 at an angle 53.1. So what is this value? So this will be 6 at an angle minus 53.1 degree. So that is the current, right? Clear? So this is the current in amperes. So what is the next one? So we need to calculate VR, voltage across resistance. So if you know the current, so what is voltage across resistance? So this current I into its value 12.
Yes, sir.
So how much it is? So this is 72 at an angle minus 53.1 degree. Agree?
Yes, sir.
Right?
Yes, sir.
Similarly, VL is, so current I 6 at an angle minus 53.1 degree into, so its value is J16, right? So how to write J16? So how to write this?
16 into e power j pi by 2.
No, in polar form. How to write this in polar form?
16 at 5 by 2, sir.
So what is that
Yes.
angle?
90 degrees.
90 degrees, 5 by 2.
16 at an angle 90 degrees, right? Agree?
Yes, sir.
So if you multiply these two, so what is the value?
96.
16 into 6. 96,
96.
right? 96 at an angle 90 minus 53.1,
37.9.
right? So it will roughly 36.9
6.9.
degrees. So this is the first one. So this is second one and the third one.
Sir,
Yes.
in sir second step, Z equals to 12 plus 16, 12 plus J16 Sir, in this right 53.1 right here.
Which one? This one.
Yes, sir.
That is the current, right?
Okay, sir.
What's your
Sir,
doubt?
in right say 36.9 degrees right.
Yeah, this one. That is the voltage.
So
We are
37.
multiplying these two.
Okay,
Tan inverse of 4 by 3 is 53 now. Or
sir, 53 degree. Then sir 90 minus
Plus
53,
53, sir.
37.
Oh, this is 37 only, no? Roughly 36.9.
Okay, sir.
See, that is exact value is minus 53.1, I think. Is it correct?
Okay, sir. Okay, sir.
Okay. Okay, anyway, that fractions that doesn't matter much, right? Clear? So next one. So how to calculate the power? So which one will absorb power here? Which
Inductor.
element will absorb power?
Sir,
Inductor.
resistance.
Only resistance, right? So the power across that inductor is 0 over a cycle, right? So how to calculate the power P? So that is I square R, right? Agree?
Yes, sir.
So what is I square? What is I square?
So minus 53 square.
36 times
36.
36 times.
106 degrees.
Right. So now the question is that right? So is that
36 at
this
an
angle is required?
6.2.
Is that angle is required?
No, sir.
Only magnitude is required.
On the magnitude.
This angle is due to this angle minus 53.1 is due to the reactive element, right? Due to this reactive element, inductive reactance, right? So that is not required. So only thing you required is 6. That magnitude is 6, right? 6 square into its R 12. So what is its value? 12 into 36 into 12, right? So that means it is 432.
Yes, sir.
Okay, right. So
Yes.
only the real component. So we'll divide. We have two components, right? One is the component with respect to the resistance and current component with respect to the inductance. So only the resistive portion only responsible for the power loss. So that's why we have written like this. If you have any doubts, so next we have a detailed discussion on different powers: active power, reactive power, apparent power. So in that, so we'll discuss. Okay.
Sir,
Yes.
if nothing is written,
Sir,
then
sir,
what?
this power which we calculated just now, sir, is it instantaneous power?
No, not instantaneous power. This average power.
Sir, if nothing is stated there, then what will be considered at the place of voltage, RMS value or the maximum value?
So here,
In like where you write V.
so here
is-
there are different notations are there. Okay, when you are converting this into, okay. So for example, we have this something like this: V equal to 120 at an angle 0, right? Someone will say that. So this is average value. Sorry, peak value. Someone will say that. So this is RMS value. Okay? So if this is RMS value, so what is the relation between RMS and peak value for a sine wave?
Peak by root 2, sir.
Sir,
Peak
sir,
value by root 2.
sir,
So that
RMS
is-
is equal to,
so
sir,
this will
peak
become,
upon
this
root
can be
2.
written as 120 sine omega t or 120 into root 2 sine omega t.
Sir, 120 by root 2, no, sir. RMS value.
So, 120 by root 2. Okay. If this is peak value, So that means this waveform is represented with the peak. That means both are valid. Someone will represent this 120 as the peak one, and someone will represent this 120 as the RMS one. Okay.
Sir, but if
No,
we
no, this is
consider
RMS
sir,
into
different, sir,
root
then
two, no?
answers will be also
This-
different. No?
This is 120 into root 2 only. So
Sir?
here we represented with peak, and this one we represented with RMS value. That 120 is RMS.
To get RMS value means we have to do square root of
So we
integral
need
I
to
square dt by integral dt.
Yeah, for example, Vm sine omega t is something like this, right? Vm sine omega t is there. So this is peak value, and its RMS value is Vm by root 2. So this can be written as, right? So this can be written as, sometimes this can be written as Vm at an angle, so 0 degrees, or Vm by root 2 at an angle, 0 degrees.
Sir,
Yes?
Okay.
53.1 degree, how to calculate, sir?
How to?
The angle 53.1 degree, how to calculate?
How to calculate means? So this
How to-
angle you are asking.
What, sir?
This one?
Yeah, sir.
So this is polar to complex, right? So this is magnitude 12 square plus 16 square into this angle is tan inverse 16 by 12, right? So tan
Yeah.
inverse 16 by 12 is 16 by 12 is 3. So you're not following the classes. Okay, we are discussing this from the past 3-4 classes.
Okay, sir.
Sir, we have considered power now, sir. Here I square R. Why didn't we consider inductive power also, sir?
So that's
due to
why
inductance.
we are only this one is power, right? If nothing is asked, right? So the power means it's I square R only, right? So there are other powers like reactive power, and apparent power that we will discuss in the later class.
If they ask power means you have to tell only I square R, sir.
I square R only. Okay. So next we have another question. We'll try to solve another problem. So let us assume that, so this is 10 at an angle minus 30 degrees. So this is Z1 and this is Z2 and this is Z3. So it is 20 at an angle 60 degrees. And this one is 40 at an angle 0 degrees. So now calculate the Z equivalent. Calculate Z equivalent.
Sir?
Yes.
Sir? Sir, in the previous page, sir, when sir we were calculating the voltage, sir, when the two angles got multiplied, sir, they actually got subtracted. So, sir, I did not understand that part, sir.
Which one? This
Sir,
one?
here 90 minus 53. Why?
90 minus 53 is 36.9, no?
So means, sir, if two quantities having their own respective angles are multiplied, then they will be subtracted.
Why? It is in division, it will be subtracted, no?
Subtracted, no?
In division, it will be subtracted.
And say in
Multiplication
multiplication,
will
they'll
be
be added.
added.
That is minus 53, bro. So minus 53 plus 90.
Okay, sir, got sir.
So minus 53.1 plus 90, right? So that will be 36.9.
Okay, sir.
Okay. So here, this one, so we need, what we have to do is, so we need to find out the equivalent impedance, Z equivalent. So this is Z1, Z2, Z3, right? So both are all are in parallel. So Z equivalent is Z1 parallel, Z2 parallel, Z3. Okay. So now, so tell me, so how to deal this in parallel circuits? So can we deal with impedance or we can deal with admittances?
Admittance.
Admittances.
Admittance,
Easy,
sir.
right? So because admittances you can easy, so that means, so here equivalent impedance, so 1 by, so Z equivalent, so this can be written as Y equivalent, so this is equal to Y1
Y1
plus Y2 plus Y3, agree?
Yes, sir.
sir.
Yes, sir.
Okay. So what is Y1 here? Y1 is
1
1
by
by
Z1.
Z1.
1 by
1 by
Z1.
Z. 1
So
by
1
10
by,
angle 30.
so what it will be? 1 by 10 at an angle, 1 by 10 at an angle minus 30, right?
30 degrees.
So that means it is 0.1 at an angle 30 degrees, right?
Yes, sir.
So what
Yes,
is the
sir.
second one? 0.05 at an angle minus
At an
60
angle
degrees
minus 60.
plus
Yes, sir.
in 0.025 at an angle
5.
0. Okay.
Yes, sir.
So you can directly solve this. You can directly solve this, or you can directly convert this into rectangle form and you can solve that. Okay. So one way, so we have this y, we have two terms, right? B term and B and J. What is B here? B1 plus B2 plus B3, right? So what is B1 here? In this, what is B1? What is B1? Is it 0.1 into sine 30 degrees? Agree? Agree?
Yes,
Sir,
sir.
B1 means acceptance,
Plus
no, sir.
0.05 sine minus 60
Minus
degrees
60 degrees.
plus
Yes, sir.
like this, the third term. Similarly, what is B and next one G, right? So G is
G.
Yes.
G1, G2 plus G3. So that is cos term, 0.1 into cos 30 degrees plus 0.05 sine 30 sine minus 60 degrees and the third term. So that also you can do. So we have B plus, sorry, G plus, so Y equal to G plus JB, right? So that you can calculate, or straight away you can add in this polar form. So that also you can do. So what is the answer? What is Y?
Once explain y1 0.1 at an angle 30 degrees in place of minus 30.
Which one? 30 degrees in place of minus 30.
y1.
So we have Z1, sorry, Y1 equal to, so Y1 equal to 1 by Z1, right? So what is Z1? So 10 at an angle minus 30. So it will be, so what is its reciprocal? So 0.1 at an angle 30 degrees, right?
I got y equivalent is equal to 0.05 into 1 plus root 3 plus 0.025 into root 3
0.05
into 1 plus root 3
1 plus root 3. What is that?
into 1 plus root 3.
You tell me the exact value, no?
Sir, y equals to 0.05 upon 2 into root 3.
No. See, I told you several times. Okay, don't say the 2 by 3, 2 by root 2, 2 by root 3 like that. So whatever the exact value, tell me that.
B is 0.0067, sir.
0 point?
So 0067, sir, B.
No. I think in book That is given 0.137 at an angle 3 degrees.
1366, sir.
Is it correct? Hmm? Is this correct? Is this correct?
Checking, sir.
3 degrees is not coming, sir.
Sir, G will be 0.137.
Hmm.
We are getting 0.137, sir. Only G. Sir.
So you have written Y
So
is
G
equal
value
to
is
sir,
0.04325.
Actually, B value is 0.137. Okay. B value is 0.137. Okay. And this G value is, so that is 0.007. Okay. So that's almost 0.
Sir, I am getting B as 0.007, sir. And G is sir 0.137.
Real part is
Yes, sir. G is
0.137.
0.137 and B is 0.007.
Yes, sir. Sir, reverse will be there, sir.
Reverse. Okay. Okay. Anyway, there is, okay. This will be the reverse. Okay. So the final one, so this is the final one, right? Is correct or not?
Yes, sir.
Okay, you can cross check it, no problem. So from this Z is, so 1 by Y. So this 1 by 0.137, so that is 7.32 at an angle minus 3 degrees. So this is the value of Z.
Every problem we have to do like this, sir.
Hmm.
For every problem
Yes.
we should consider like this notation, or we can solve in another method also.
So not necessary to solve this one. You can directly do this in Calci, right? Okay.
Okay, sir.
Just for illustrative purpose, I discussed this. You can solve like this. You directly in calculator, you can do this, right? Or you can convert each one into its rectangular form. So again, this way you can convert into x plus jy form. This is you convert into x plus jy form. This you can convert into x plus jy form. Okay. Okay, I'm moving to the other problem. So you got the procedure, right? So when you have parallel circuits,
Yes, sir.
you must deal with the impedance. In series circuits, we have to deal with impedances. In case of parallel circuits, it is better to deal with admittances, right? So if two circuits are there, for example, only two elements are there, so no need to go for with this. So you can straight away use Z1 into Z2 by Z1 plus Z2. So that's two are in parallel. For example, if three are there, so in that case, it is difficult, right? Parallel of three elements is slightly different. So in that case, you can use any other these methods, right? So let's we solve another one. So this 230 volts supply is 50 H. Okay, so this is 20 ohm, and this is 0.1 Henry. Is 50 ohm and 40 40 microfarad. So calculate the current I. Calculate the current I.
So here 230 should be taken as RMS value.
Yeah. So here in electrical, so whenever they're mentioned, if nothing is mentioned, right? So that means, so this is RMS value. Okay. So this is RMS value. So how we will represent this source as, so we have Vm sine omega t format, right? So Vm, so what is Vm if this is RMS value?
So 230 into root 2.
230 into root 2 at an angle 0, right? Or in other words, 230 into root 2 sine omega t. Okay, if nothing is mentioned, so that means it is RMS value. So that means this we will represent as 230 into root 2 sine omega t. So unless specified, it's peak value or something like that. So this is 230 into root 2. Okay. So what is thing? So here this actual values are given. This is given in inductance, this in henries, and this is in farads, right? So how to convert this?
Omega.
IL omega minus J by C omega.
So how to do that? So you need to multiply with omega, right? So how to obtain omega?
50 hertz.
So frequency is given, right? So that means
Yes.
from 50 Hz, you have to calculate that. So let us assume that, so this entire thing is Z1 and this entire thing is Z2. Okay. So what is Z1 here? 20 plus
So
J
20 plus
omega
31.4 J.
minus
50 into 0.1, right?
Yes, sir.
Yes, sir.
So what is this value?
The 31.4.
20 plus J 31.4 ohm, right?
Yes,
So what is Z2?
Yes, sir.
50 minus J 2 pi
40.
Into
J
40.
into 1 by, no, it is 1 by omega c,
by
right?
Yeah, yes, sir.
1 by
The
1000
in
omega
1000 upon 4
2
pi.
pi f into 40 into 10 to the power of minus 6.
Minus, sir.
So what is this value?
79.62.
79.5.
79.6.
हाँ sir, approx.
79.6. Okay. Clear? Right. So here for the first thing is we need to calculate the current, right? So current I. So these two are impedance, right? So how to deal these? So this equivalent Z equivalent is, so Z1, Z2 both are parallel, right? Agree?
Yes, sir.
Yes.
So how to solve this? Either directly you can solve this. So that means Z1, Z2 by Z1 plus Z2, right? So what is Z1, Z2? So that means multiplication of these two by division of these two, so that you can solve. Or else you can convert into its polar form. So what is its polar form here? So you can convert this into its polar form, and also that you can also do. Or you can convert this into its equivalent admittances. You can calculate y1, y2, and also you can solve. Right? Agree?
Yes, sir.
Or you can solve in other way. So there are numerous ways to solve this, right? So first you calculate Z1, Z2, and you calculate the Z. So from that, you can calculate V by Z equivalent. So that is I. So you calculate like this, or so you can calculate equal to y equivalent equal to y1 plus y2. So from that, you can back calculate Z equivalent. So from that, you can calculate I value. That is another method, right? So there is another method. So you can directly calculate this IA value, this I1. This is I1 and this is I2, right? So what is I1 here? I1, what is I1? So this is 230. 230 at an
Vm
angle
upon
0 by 20 plus J.1 Henry, right? No, not J.1 Henry. This is J 31.
So J 31.4.
Okay. So this I2 is 230 at an angle 0 by 50 minus J 79.6.
79.6.
This is amperes and this is amperes, and I equal to I1 plus I2. It's the phasor sum of I1 plus I2. So that gives you I value. So tell me, what is the value of I? There is no unique method. So we can several approaches are there. So based on your computational time and your speed, so you can select one method. So tell me, what is the value of I?
Check answer. You can't hate answer.
Classic,
What is the value of I?
I1 is 6.18 at an angle of minus 57.5 degrees. I1.
No. Tell me what is overall I value. What is I1? You got how much? 6.18.
6.18 at an angle of minus 57.5 degrees.
Minus 57.5. Yeah,
degrees.
I think this is correct.
I2 I'm finding, sir.
So you can find that. So I will write the value. So it is 0 and this is 85 at an angle minus 34.34. So this will translate into 2.7, right, at an angle 34.34 degrees. So amperes. So this is the value of I. You got the final answer is 2.7 at an angle 34.34. Okay, you can cross verify. So we'll move to the next example. Okay. So we have some problems, something like this, for example. Say this is 12 ohm and this is J4 ohm. This is 8 ohm and this is minus J3 ohm, right? And this is J6 ohm. And this is 8 ohm. This is 2 ohm And this is inductor actually. So this one is capacitor. So minus J4 ohm. So I'm teaching from the textbook, worked out examples so that you have answers and I can cross verify. So for this particular problems, you need to calculate the value of current phasor I. So how to solve these particular kind of problems? If you observe that, so this circuit, so neither in series or nor in parallel, right? If you clearly notice that, so these three elements, particularly this one, and this one. So what it exactly making?
Sir, why?
Connection, right? By connecting minus star connection, right?
Star
So
connection.
what we have to do is
Star connection stage.
so we have to find out its equivalent delta connection, right?
Delta
So
connection,
this
yes, sir.
equivalent delta connection will be something like this. Its equivalent delta connection will be something like this, right? So how to find out that values, whatever the star delta conversion, so we are using, right? So those same formulas, it will be applicable here. So that means these formulas will be something like this. For example, if you have a delta connection, so for example, this is ZA and this is ZB and ZC. All right. So inside this, it's equivalent star. Say for example, this is Z1, Z2, and Z3. So we can convert this into star to delta. So for star to delta, so what are the formulas? So star to delta means, so that ZA, right? So what is ZA? So how to calculate ZA?
Sir, Z1, Z2 plus Z2, Z3 plus
Z1,
Z3, Z1 by
Z2
Z.
plus Z2, Z3 plus Z3, Z1 by
Z1.
Z1, right?
Z1. Z1, sir.
Similarly, ZB and ZC. You are aware of these
Yes,
things,
sir.
right? So from delta to star, so what is Z1? So this Z1. So these two, right? So ZB, ZC.
Yes, sir. ZB,
So
ZC
ZB
by
into ZC by ZA
ZA plus ZB plus ZC.
plus ZC.
ZC.
Agree? Same thing. So if Z1, Z2 are same, Z1, Z2, Z3 are same, in that case it will be 3 times. In case of star to delta, in case of delta to star, so it will be 1 by 3 times. Okay. The same is applicable here, whatever we discussed, so that will be applicable here, right?
Sir, means we have to take impedances, sir.
Everything is same. Only thing is that we need to deal with impedances. That's all. So that's why it is Z. So this Z means it is combination of R, L, and C.
Okay.
Okay, so now tell me, let us assume that this is Z1 and this is Z2 and this is Z3. So what is Z1?
How should I tell the final answer of Z1?
No, what you tell me, what is the in which format it will be Z1?
Sir, the adjacent one are ZB and ZC, sir. 4J is ZB, 8 is ZC, sir.
Yes.
4J ohm is ZB and 8 ohm is ZC, sir. We have to take like that. Adjacent one are the alternating or the complementary ones.
No, what is Z1? So how you do that? What is the formula for
8
Z1?
into 4J plus 8 into
ZB.
2 minus
8
3J
into
plus
8 into J4
4J.
plus
Yes, sir. Plus 8
J4
into minus
into
J3.
minus J3 plus minus J3 into 8, right? Agree?
Yes, sir.
So what is the
5
denominator?
minus J3.
Minus J3.
Minus
Minus
J3.
J3, sir.
Okay.
J3, sir.
Minus J3, right? Clear? No confusion, right? So similarly Z2, so numerator is same. So only thing, what is changed here? What is
By
the
8, sir.
denominator?
The denominator change.
Denominator change. So J4.
Denominator change.
What is that? What is the change here? Numerator is same, right?
J4.
What is the denominator here?
J4,
J4, right?
J4.
Here,
Yes, sir.
in the last one, you can numerator is same.
Sir,
8 ohm.
8 ohm.
Sir, 8.
Okay. So now tell me, what is this Z1?
Z1 is minus 8 by 3 plus 4J, sir. Minus 8 by 3 plus 4J.
Minus 8 by 3 plus 4J. So always tell J4. Okay. Minus 8 by 3 plus J4, right? So what is the second element? Z2. What is Z2?
So 2 minus J3.
2 minus
J3.
J3.
Sir,
What is
minus 8
Z3?
by 3 minus J4, sir. First one. First one minus 8 by 3 minus J4, sir. Both minus.
Is it correct?
Yes, sir. Minus 8.
Which one? Plus J4 or minus J4?
Plus J4 only, sir.
Minus,
Minus
sir.
J4.
Minus.
Minus.
Okay, minus. Anyway,
No,
you
sir.
can
No, sir.
cross
Plus,
check
sir.
it.
No,
Plus.
sir. No, sir.
Plus.
Plus only, sir.
Plus only,
Denominator
sir.
we have minus.
Sir, and Z3 is 3 by 2 plus J.
Z3 is 3 by 2.
Plus J.
J, okay. Only J1, right? Okay. Okay, it's clear. So these are the values, right? So now you can eliminate or you can delete these, right? So now you can delete this, right? So here instead of this one, so Z1, right? This is Z1. So Z1, so instead of this Z1, so you have some element, right? So this element is minus 8 by 3. So how it will be minus 8 by 3? Is this correct?
Yes, sir. Minus 8 by 3 is correct, sir.
What does it mean? That will be resistance, right?
So that will be resistance, sir.
It's supposed to be plus, no?
But on calculation, we are getting minus 8 by 3 also.
Okay. Can we write in the other way? So it will be 8 minus 3 minus J format. So can we do like this?
Taking minus
Again,
common
by
and writing
multiplying
J
with
square.
J4 into plus 8. You can alter this format, right? So how to alter that? So multiply with J4 plus 8 by 3. So multiply with J4 into J4 plus 8 by 3, J4 plus 8 by 3. We can change its format, no? So because resistance, you cannot change, start with minus, right?
Sir, but even if we consider, sir, minus 8 by 3 only, sir, then and sir, afterwards, so it will be, sir, come into its original form itself now.
No, you cannot see, you cannot represent a resistance at minus 8 by 3, right? Okay. Just it's a calculation, right? What is its equivalent calculation? I think when you're placing this minus, right? So this minus j, you can change the format, I think. What is its equivalent value? You got it, right? 8 by 3 plus j4, right? So here, so we need to multiply with plus 8 by 3 j4, 8 by 3 j4. Multiply and divide by plus 8 by 3 j4. You're getting this? Or I can multiply with minus 8 by 3 minus j4. Or what we have to do, minus 8 by 3 minus j4. Is this is the format?
Yes, sir. That's correct.
This one, right?
Yes, sir.
This one we need to do, I think.
Yes, sir. That's so. Complementary, we should multiply.
The complementary had to do that, right? So do this and tell me.
Then also we are getting real part negative only, sir.
No, we are multiplying with minus 8 by 3 minus j4. No, in this case you won't get negative, I think.
So here also are getting real part negative only, sir.
Is it?
But again, we'll have complex number, no, sir, in denominator.
Okay. So in that case, you can straight away use that
I
Z1.
think it's better if we alter the angle, sir.
Where? So in that case, you directly use this. This is Z1, and you can proceed with that. Okay.
Okay, sir.
I think somehow we need to convert that. I don't exactly remember. Okay. So for example, a minus jb is there, right? For example, minus a plus jb format is there. So you can write these things. I think some, or you can by directly dividing with j into multiplying with j, or you can alter these things. Okay. That I don't remember. I think we need to multiply with minus j. So what else if you multiply with minus j minus, is there any change? Or still it's same? Okay, we have to look these things. So these are complex operations, right? So you can revise your complex operations so you can bring this into some x minus jy form. So you can bring this into x minus jy form for actual representation. Okay, there is no wrong. You can directly use this z1. Instead of z1, you can use that minus 8 by 3 plus j4. So there is nothing wrong here. So the final answer for this particular problem is 3.666 at an angle minus 4.2 degrees. So that is the current. Is clear? So this is how to apply a star and delta connection in case of the circuits are so having there is neither series or in parallel. So in next class we'll study how to apply mesh analysis and node voltage method. So in this AC circuits. So next class we'll see how to apply nodal analysis and loop current method or the mesh analysis for these AC circuits. So you have any questions? You have any questions?
No, sir.
So then if you have no questions, we'll stop here.
So when could we have a